Hello. I wanted to make a bonus video following my TRPO implementation video. And here actually I wanted to test whether my implementation can teach the something else to basically act. In this case, I want to try the quadruped, and you can see it kind of after many iterations it has learned to walk a bit clumsily, but still it's quite impressive. And actually the goal of this robot quadruped is just to move in this red line direction, so x-axis direction. And it's an interesting environment. Maybe I will just discuss it shortly. So this quadruped, actually this is one of the environments which is part of this Mujoco environment. Unfortunately, I could not install it because I use Windows, and it's not simple. It's not very simple. It requires you to have a Linux OS, and actually I don't want to do it because it is just kind of a hobby. It kind of, I think it's a difficult environment, much more difficult than some previous stuff that I've discussed, which was mountain car and double pendulum, acrobot, and all this stuff. You see that it has 8 continuous actions, 4 legs, 2 joints, 27 observations, positions, and angles of legs and its body. The rewards basically are interesting because it gives you +1 reward each basically time step that our quadruped is healthy. Probably it means that it's upright, or it kind of, I don't know what healthy means in this case, but in this environment it is healthy, quotes unquotes, pretty much all the time. And it receives positive rewards when it moves forward, but it receives negative rewards, penalties for jerky, sporadic, spazzing basically movement, and some penalties related with forces exerted on the ground probably. So kind of positive reward ticks each step, so movement positive, but your actions are quadratically penalized, and also forces, something related with forces. What I did here is I've repeated some aspects that you can see in this publication by John Schulman on generalized advantage estimation, when they have also this quadruped and they basically truncated by 2000 steps, because this environment is kind of endless. You can stroll around endlessly. And basically, maybe I should mention how I actually implemented. I did not implement it, but you can see that this is, where was it? You can get this basically environment using the library Jiminy. It includes also the basic stuff, card pull, acrobot, pendulum, but also you see it has an ant, which is our quadruped, and some other stuff. And I think ant is a kind of nice middle ground between something too easy and too difficult. So it's kind of cool. Our boy walks. Right, I've used basically 2000 steps for each episode, and also the scale divergent truncation of 0.05. I will show you later, but basically from my previous learning, I have left only this plot of objective function because I didn't save the data on only the neural network weights, and you can see this kind of exponential decay, at least in absolute terms. And also you can notice that TRPO is triggered, so basically it doesn't use the NPG step, it makes one step kind of closer basically to the original parameters each time. So maybe I'm overestimating, but still I think maybe it's faster. Okay, maybe what about this decay? Yeah, kind of you see that there's some kind of saturation, but then maybe you might think, okay, maybe at this time where it's kind of our learning is saturated, maybe at this point your quadruped already walks like a pro. And it's not the kind of it's not how it is actually. If you have watched the simulations of what the robot does, it just stumbles around, although the learning curve is saturated. Okay, yeah. So actually, if you look at this graph, that you see that he's just actually at this point stumbles around and doesn't actually do the main goal of walking forward. And I will maybe try to explain why it happens. Actually, when I've encountered it, I was kind of disappointed because I thought maybe my algorithm doesn't work. Actually, maybe it doesn't work actually properly, right? I won't deny it. Although he kind of learns in the end. Yeah, but why this saturation next to 200, 2000, basically this kind of reward? It's not average cumulative. Actually, it's not. It's an old plot, at least titles. And what I do, it's a sum of rewards over each episode. So I kind of have this batch. It consists of chunks, and I sum over all the accumulate the rewards in an episode, basically, yes. And then I take the average of this. So I have like 5 episodes and sum up all the rewards. So it's not cumulative here, in fact. Yeah. And as I've noted that how the rewards are defined, in fact, this penalty for jerky movement, I think quadruped is trying to basically negate this at first. And actually, I guess I've noted also that I do 2000 steps, and apparently it's related somehow. So yeah. So in a sense, our robot is trying to survive at this point for 2000 steps. So it tries to stay healthy, and it tries to combat either this action loss or this forces loss or combination of this. So in fact during this stage of learning, basically as it approaches 2000 steps, it mostly tries to fight them, and it just tries to survive. Basically, if it would stay in one spot without moving, it would not gather these penalties, but it would receive the rewards of 2000 points just for existing, just for surviving. And that means actually it doesn't care, it doesn't try to gather this moving forward reward, which in my opinion is kind of the point here. And that's why after 2000 iteration, you look at him and yes, it doesn't jump, it doesn't do backflips and such, but also it doesn't move forward. It kind of accumulates something, some movement, or it negates it by moving backwards, but still. And actually what you have to do is actually to continue training him. And here I've set up the second phase where I've trained him for more iterations, 1600 and a half. And basically, yes, it pushes past this 2000 point reward up to 3000 and more, and it doesn't even basically stop. I think at some point it will have to optimize for limited episode length, so it will just try to move as basically in a straight line, as much in a straight line as possible, but not at this point. At this point, you see, it still learns to walk. Actually, it walks kind of clumsily, but still, it's very impressive in my opinion. Maybe, what about details? Yeah, I'm using this library, basically Jiminy. It has a gym kind of a wrapper in a sense. I can plug this class of this ant environment into my basic environment wrapper over gym. It's not a wrapper, it's this custom stuff, but still it just works straight from the box. I've defined my neural networks of actor and critic with 2 hidden layers. I've created this kind of module with all the required stuff, multi-layer perceptrons and stuff, all the old stuff. So there's almost nothing new except that maybe in my training wrapper I've made similar to what they made in spinning up TRPO implementation. When you check, it switches from discrete to continuous action implementation depending on the actual action type, basically action space type. Yeah, a few additions of saving and loading weights. This training procedure is implemented as a function. One small difference I made, which doesn't play actually a role here, is I've decided to, as I've noted previously, that implementation basically in this algorithm description, it used what it used. Let's scroll down. Basically, our gradient was calculated as a mean of sums over or episodes. Yes, so I've decided just to, and previously I've used only the mean over everything. So in this case, because our quadruped lives whole 2000 steps, it kind of makes no difference. But still, maybe if some episodes were shorter and other longer, it would maybe make difference, but I cannot decide yet. So basically I've implemented this approach, so I do summation and then I take a mean of sums. It's not apparent to me right now whether it's the same stuff. It shouldn't be. So it's a small modification, which means I just do this. I use my chunks to split data. Why it's interesting, you can see it. Each chunk is a view of original tensor. That means it doesn't shift anything in memory probably, so it's kind of efficient. I haven't seen this particular implementation. I've seen masks and such, but probably it was related to parallelization and stuff. So yeah, that's a small addition. And probably that's it. Yeah, kind of. Um, so what are the takeaways? Maybe we shouldn't basically rush to conclusions when our training curve saturates and our agent doesn't behave properly. Maybe we should actually analyze what could possibly be going wrong. Uh, just a sec. So let's watch another episode. He's making this weird upward motion with his legs, which is hilarious. But yeah, I think it's a great success. So I hope maybe it helps you, maybe inspires you, whatever. So yeah, thanks. That's it.